Hi everybody, and welcome to my tutorial on how to get a perfect score and solve the AP Calculus BC 2011 free response question number 3 on the AP exam. Today we'll be focusing on remembering some key AB topics as well as the sole BC portion of this question dealing with arc length. So here it is. The problem reads, let f of x equal e to the 2x, let R be the region in the first quadrant bounded by the graph of f, the coordinate axis, and the vertical line x equals k, where k is greater than 0. The region R is shown in the figure above. We're being asked to A. Write but do not evaluate an expression involving an integral that gives the perimeter of R in terms of k. B. The region R is rotated about the x-axis to form a solid. Find the volume V of the solid in terms of k. And C. The volume V found in part B changes as k changes. If dk over dt equals 1/3, determine dv over dt when k equals 1/2. I think it's always a good idea to read every part of the question before we even start writing anything, just to get a general sense of the problem as a whole and to anticipate what's to come. For instance, in the case of this problem, I never would have expected related rates to show up here, but it did. So that's why I recommend reading the entirety of the problem before you even start working. Okay, so the first part of this question is asking for the perimeter of R. Right away, we should make sure that we take into account of every side we are going to be adding for the perimeter. Looking at the graph, we have 3 lines and a curve. Now, what makes this problem so easy is that all you need to remember to score all the points on this part is the arc length formula of a rectangular curve. 3 of the 4 sides are lines, so we'll take care of those first. That's pretty straightforward, so now let's move on to taking care of the arc length of the curve. Now if we remember our formula for the arc length of a rectangular curve, which is shown, this is a very simple problem as it only requires you to take the derivative of a function and then throw that derivative into the arc length formula. And there we go, that's our answer. The scoring guideline of this question gives you 1 point for f prime of x, 1 point for the integral, which we can assume has to be a correct integral, and 1 point for the answer as a whole, the sum of the sides of R. You would likely have missed all 3 points for this question if you didn't remember the formula for arc length. You would not have known to take a derivative and would have likely gotten an incorrect integral and thus an incorrect answer. That is why it's very important to know the rectangular arc length formula along with the parametric and vector arc length, of course. Part B is to be expected out of these types of problems. We're going to have to rotate the region R horizontally about the x-axis. I'm pretty confident that most of you guys know how to do the setup for the integral, so I'm not going to spend too much time explaining it, and we're just going to move into anti-deriving it. So there's the integral setup, pretty self-explanatory, and now we have to integrate and evaluate the limits. So quantity e to the power of 2x quantity squared is e to the power of 4x. I'm sorry. Then we have to integrate it. We have to remember to count for the chain of 4x, so we divide it by 4, and then we can just multiply it by pi as well. Now that we have our antiderivative, we can simply evaluate it for the limits of the integral, which are k and 0, and boom, there's our rotational volume in terms of k. Scoring for this problem is pretty straightforward, with 1 point for the correct integrand, including the pi out front, which I know many of you might forget. 1 point for the limits, which is an easy point you can grab for just setting up any integral. 1 point for the antiderivative, and 1 point for evaluating your antiderivative to get your answer. The scoring guideline was very clear on what steps were necessary to get this problem correct. You can score a very generous 4 points on this question, which I think is not too challenging. It is very important that you are knowledgeable on AB topics for the BC test, because this is an easy 4 points if you have rotational volumes down. Finally, for part C, they're throwing something a little unexpected at us. Upon first glance, I was a little unsure of this problem, as I know we learned related rates way back in Calc AB. However, this particular one is actually very easy. So using the rotational volume we found in part B, we're going to differentiate it with respect to t to find the rate at which the volume is changing when k equals 1/2. So if we take the derivative of our volume function with respect to t, our dv over dt function is going to look something like this. We're going to chain the 4k in the numerator by multiplying it by 4 times dk over dt. There's a chain of dk over dt because we are differentiating with respect to t and not with respect to k, so it's crucial that you recognize that and don't forget the chain rule. Now that we have our function for the rate of the volume, we are going to make two simple substitutions for k and dk over dt, and that will give us the rate of our volume when k equals 1/2. Had you not known to chain the k when differentiating for t, you would have likely missed both of the 2 points of this problem. The scoring guide gives you 1 point for applying the chain rule, and if you hadn't, you probably would have missed an additional point of the answer. And there we have it, the 2011 AP Calculus BC FRQ number 3. Here's what you should take from this video going to the AP exam in the next couple of weeks. The most important thing is to be fresh and confident in AB skills. 6 of the 9 points on this FRQ were completely AB topics, and that is on top of the 3 completely AB FRQs. So technically it is possible for the BC FRQ section to be more than half AB topics. Knowing this, you must refresh your memory on important AB topics that the College Board likes to ask about, such as rotational volume, cross-sectional volume, related rates, optimization, and etc. And with that being said, I think that just about concludes this video. Thanks for watching, guys, and I hope it was helpful. If you want even more practice, I linked a mock FRQ that is very similar to this one and that I made myself, along with a few other similar problems from the textbook and online that you can look at too. Goodbye.